Hello, my name is Lyuben, and if you're watching this video, it means I managed to make it to the Cassandra conference, so good news all around. In this video, I'll talk about the application I entered into the data stacks competition, what it does, how it does it, and what technology I used. CasTor was created because a new law that might be passed in the UK. The new legislation would force internet service providers to monitor all of the traffic generated by its users, with a heightened interest into traffic involved with communication programs, including emails and messaging programs. CasTor is a proof of concept that the communication channel can be secured from your ISP by using Cassandra and Tor, the anonymity network. Cassandra was used in CasTor for a variety of reasons. The two most important reasons being that Cassandra's port usage couldn't be linked to emails in any way, and that Cassandra allows you to build a highly distributed system. If a company ran a central email server, then clients would be reliant on that company maintaining the server. If, however, the email service was based on each client's machine, then clients would only be dependent on people actually using the system. Tor was used to mask users' IP addresses, allowing for anonymous usage of CasTor. And now for a brief 2-minute demo showcasing the application. We'll begin by showing off the current cluster that we'll be using for today's tutorial. We have 3 nodes, they're connected in one cluster, each has 100% of the data, and this is because they're storing a brand new blank key space which will just be used for the messages. Let's begin running our application. Because it's the first run of the application, there are some terms of service and some instructions what you need to do to get the node started. As you can see, the application created a new Cassandra folder on the desktop. This will be our server that will be connecting as a new node to our cluster. Once we click OK here, the new node will be bootstrapped into the cluster and it will be ready for use. So after waiting a minute, hopefully our new cluster will be all ready and connected. Let's see by running the node tool command again. As you can see, the new node 105, this one, is now part of the node, part of the cluster, and it's ready for use by our application. If we rerun the client, because it won't be on the first run anymore, it'll connect through Tor and display the interface that we use for doing messages. Now we can simply log in, you can pick any username, and you'll be ready to get started. You're displayed with a really simple interface to create new messages. I'll send a message to James B. And hopefully, once we log out and log in with James B, the message will be available for him to see. As you can see, there's the new message, and that's our new node connected to the cluster without us having to do any work whatsoever. And now for a more detailed look into how Cassandra was used in CasTor. Cassandra was the only database used for the application. In this slide, I'll provide an overview of how the data was modeled in the CasTor application. Since I wanted to avoid simulating joins in the client-side application, the data ended up being fairly unnormalized. 2 key spaces were used with a column family each. 1 key space to store the users and their passwords, and the other key space to store messages. Secondary indexes were used to allow for more flexible querying. CCAL was used throughout the application using the Austonics client due to the client's SSL support, which played a very important part in securing the communication channel. Since I'm using Cassandra, I felt that I have to take as much advantage as I can of the technology's ability to scale. This led to CasTor's distributed architecture, where each user has their own local Cassandra database set up by the application. This allows the system to be distributed across its users rather than depending on a central server. Each time CasTor bootstraps a new user's local Cassandra server to the cluster, the replication factor of the message key space is incremented, meaning that each node still contains all the data stored relating to messages. This allows the system to be running without any problems even when users switch their machines off. So how was my experience of using Cassandra for my project? I would say a really pleasant experience, and I do think Cassandra is the way to go if you need a distributed system. I'm used to spending lots of time trying to work out how to get anything started, especially with servers, but I had Cassandra running within minutes the very first time I downloaded it and used it, so it was very easy to set up. I've had bad experiences in the past when it comes to clustering databases, but Cassandra made it very, very simple to get stuff done really quickly, and it's really easy to expand clusters and build very, very big clusters with a lot of machines in them. I found client-side SSL to be a bit difficult to set up. The other problem I had was with the authentication key space I used, because I couldn't afford to distribute users' passwords to everybody, even if they are hashed and encrypted. It wasn't safe. And because I didn't have control over writing to only one node, I ended up using a separate server for that. The final problem I had with Cassandra was bootstrapping between different operating systems. 9 out of 10 times it worked, but occasionally it would crash and it wouldn't be the same error every time, so I decided to just branch the applications into different systems. What I liked most about using Cassandra was the community. A lot of helpful people on Stack Overflow and everywhere really. Even the blogs on Planet Cassandra were very helpful. Also, the open source aspect of the project, it made it very easy to find source code and work out what errors I'm getting and how to fix them. Well, that's my presentation. Thank you for watching and listening, and I'll be more than happy to answer any questions you might have.